going to do an example about a sample t-test, two sample t-test for the difference of two means. Okay, the scenario begins as a Cornell student wanted to discover if buying from a friend or buying from a stranger actually influenced prices people thought they would get. So the setup says she randomly divided her subjects into two groups, and she gave the groups a description of the items that they may want to purchase. One group was told to imagine buying it from a friend whom they expected to see again. The other group was told to imagine buying from a stranger. And each time, the individuals were asked to quote a price, what they think if they bought it from a stranger or from a friend. Of course, those are in separate groups. What would they expect to pay? So, and you can see in L1 here, we've got the prices. If someone thought they were buying from a friend, what would they expect their friend to charge them? And so you can see in L1 all the prices, all 8 of them. Now L2 contains the prices that the group that thought they would be buying it from a stranger, how much would they expect their stranger to actually sell them the object for? And this was for a used camera in good condition. Okay, so what we're going to do here is we're going to start off by basically identifying our parameters. What am I trying to measure? What's the purpose of this? Here again, we are looking at the difference between means. I'm really wanting to know what the difference is, if it's a stranger is more expensive or if buying from a friend would be more expensive. You want to know whether people are more likely to offer a different amount for a used camera when buying from a friend or buying from a stranger. Okay, so we're looking at the differences, not the actual individual values of the means. All right. The next thing we're going to do is, because we're doing a significance test, that we need to state our null and alternative hypotheses. The null, basically in this case, is the difference between the price offered to a friend or the price offered to a stranger would be 0. And we'd write that the mu of a friend minus mu of a stranger equals 0. Alternatively, we would state that the difference in the mean prices is not 0, because we're not really sure which one's more, which one's less. We just think, well, is there a difference between the two? And so we'll state mu of a friend minus mu of a stranger is simply not equal to 0. All right, let's look at the box plots of this data. Go up to our stat plots. Now I've already plotted these to save a little bit of time, and so we'll go straight to zoom 9. And you can see the box plots here. Now this is considerable differences. And of course, remember our first list is the list from buying from a friend. The bottom box plot is buying from a stranger, and it's very obvious that people think that if they're going to buy it from a friend, they're going to get charged more money. If they're buying from a stranger, they're going to save a deal. Of course, they don't know if they're going to get a piece of crap or if they're going to get a real deal or not. So maybe buying from a friend, you pay a little more just to be sure that you can trust where it came from. I don't know. But that would be some things that you would think about when you look at the data the way it is. There is a little bit of overlap, but let's talk about what you see in the picture. Okay, so you're looking at your pictures. You've got shape, center, spread. Okay, we want to compare these groups. We look at it and we think, well, the median measurements, obviously, the friend median is way higher than the stranger median. The spread median, the spread for the friend is very small. The spread for stranger, pretty large. Both of them would appear to be somewhat symmetric, somewhat normal. Let's look at some other plots just to kind of further look at those things. So we'll go into plot 1, and let's look at a histogram just to see what that looks like. Okay, so we'll go here, and I'm going to go to plot 2 because I don't want to plot a histogram and a dot plot all at the same time. So I'll turn plot 2 off first. Okay, we're going to hit zoom 9. You're looking at it, you're thinking, ooh, that looks kind of weird. You're buying from a friend. Is this normal? Remember, when you just have a real small sample size, it's real difficult to tell when you're looking at a histogram. Let's go back and look at the normal probability plot. Maybe that'll give us a little better picture. The normal probability plot is the last icon under type. Looks kind of like a dot plot, just a set of lines. I'm going to leave my data set just like it is. So zoom 9. And you go this way, and it's not exactly a straight line, but you can see that it fits onto that straight line pattern. So in this case, your normal conditions, they're unimodal, like there's no bimodal situation, and they're fairly symmetric. So we're going to go with it. It's not totally skewed in one direction or either way. Alright, so we'll go back and we'll do the same thing for the second plot. This time I'll just go in and I'll change the data list from L1 to L2. And I'm going to keep with the normal probability plot. That seems to be a better visual. And this one looks much more linear, although you can see some sort of a curve to this. Now remember, we're not doing linear regression, so finding a curved pattern isn't that critical here. You just wouldn't want all the dots to be on one side of the curve and several ones to be over here. That would indicate outliers, or you wouldn't want two humps or things like that. But let's go ahead and look at this as a histogram. Since we did the other one that way, we'll do this one as well. Okay, I'm going to go down and choose histogram from my choices, and everything else should line up. Okay, zoom 9. And this one looks pretty good. As far as normality goes, you would feel comfortable looking at this one. Alright, so we'll go back to our stat plots. Actually, we'll just go back to our data. Now, let's talk about our assumptions. Now, the one we just looked at was the nearly normal condition here. Okay, and we looked at the normal probability plots. We looked at the histograms. Both of them worked out to be what we call nearly normal. Okay, the next one we have the randomization. The experiment was a randomized experiment. They stated that in the problem, and so you don't have to worry about checking that. You simply just reference that in the problem itself. Okay, and then the independent groups. Okay, here again, they also discuss the fact that the groups were independently given questions and told different things, and neither of them had any kind of influence over the other. So here again, reference that from the problem at hand. All right.